Hello everyone, my name is Chauhan. I'm assistant professor in SGVU-Pharmacy, that is a part of the University. We are going to discuss the topic that is the cycle games, and this is the last unit, that is the fifth unit of this pharmaceutical organic chemistry second, and which comes in your third semester in your second year. So here we are going to discuss the cycloalkanes. What are the cycloalkanes? What are the properties of cycloalkanes? And cycloalkanes come from the word alkane, and all of this we are going to discuss in this today's lecture. Let's start. So the learning objective of this topic, that is a cycloalkane, is that here we are going to study about the cycloalkane. Also, we are going to study about the nomenclature of cycloalkane, how we are going to name it, this cycloalkane, and and also we are going to learn about the physical properties of cycloalkenes, that what are the physical properties of the cycloalkene as compared to the alkanes. Next is the student outcome. So the student outcome is that they will going to know about cycloalkanes. They will also going to know about nomenclature of cycloalkane. They will be they will also be going to know about the physical properties, that is the density, solubility, boiling point. These are the physical properties that we are going to study in the cycloalkanes. And also we are going to study about the nomenclature and what are the cycloalkanes. Nomenclature means that how to give the name to the cycloalkane according to the IUPAC system or the common system. So here, all of this we are going to study in this today's lecture. Let's start our lecture. So the cycloalkanes. The cycloalkanes are alkanes which have some of this carbon atom arranged in a ring, rings of different size, beginning with 3 carbons are possible. Means here that cycloalkanes are alkanes which have some of their carbon atoms that are arranged in the ring, and the ring of different sizes beginning with 3 carbons are possible. So in this cycloalkanes, these are the alkanes. Means they are the alkenes. These are the saturated hydrocarbons. Saturated hydrocarbons, the saturated hydrocarbons in which they have the single bonds between the carbon, and they are occurring as or they are arranged in a ring, and they are arranged in a ring. These cycloalkanes are having the carbon atoms that are arranged in a ring. So the ring that is the smallest ring or the beginning of this cycloalkanes occurs with the 3 carbons. Means here 3 carbons. 3 carbons are possible. 3 carbons are arranged in a ring, or this is the 3 carbons which are arranged in a ring. That is the starting of this beginning of this cycloalkane. So here the ring of different sizes, but the beginning starts with the 3 carbon atoms which are forming a ring or arranged in a ring. So here cycloalkanes are saturated since all the carbon atoms that make up the ring are single bonded to us. So here the same the cycloalkanes are your saturated hydrocarbons. Um, Saturated hydrocarbons that are arranged in a ring because they are having a single bond between them. So they are the cycloalkanes. If there is a double bond between this ring, then there is a then we will call it cycloalkenes. So these are the cycloalkanes. These are the saturated, as you can see in this structures. That in the first, that is the CCC, that is forming a ring of 3 carbon atoms. So this is the beginning of this cycloalkane, and as you can see, this carbon is arranged. 1 carbon is attached to the 2 hydrogen and the 2 carbon atom. So a and all the carbon atom have the same structure, that this carbon atom is arranged. This is arranged with this carbon atom. This carbon is arranged with this carbon atom. and this carbon is arranged with this two hydrogens. This carbon is arranged with two hydrogens, and this carbon is arranged with the two hydrogens. So this is forming a beginning of this cycloalkane, that is the cyclopropane. So its name is the cyclopropane. Why? Because here three carbon atoms are there, and this is a cyclic compound, so its name is cyclopropane. So we use for the three carbon atom. Next is your this. This is your four. This one, two, three, four. In the same, this one carbon is attached to the two carbon atom and two hydrogen atoms. And this is having the four carbon atoms. So its name is your cyclobutane. Cyclobutane. This is having the five, one, two, three, four, five carbon atoms, and in this the same the two hydrogen. One carbon is arranged, attached or bonded with the two hydrogen atoms and two carbon atoms. So its name is cyclopropane, cyclopentane, because here five number ring is this. Next is your this. So this is in this the six carbon atoms are there. One, two, three, four, five, six. So in this six carbon atom, the one carbon is arranged with the two hydrogen atom and the two carbon atom. Similar, all the same in this cyclo, all one carbon is attached to the two carbon atom and the two hydrogen atom. So once again, the cycloalkanes are alkanes which have some of their carbon atoms that are arranged in a ring, and the ring of different sizes. Ring of different sizes beginning with three carbons are possible. And these are the structure of this cycloalkanes, that is the cyclopropane, cyclobutane, cyclopentane, cyclohexane, and the cycloalkanes are your saturated, since all the carbon atoms that make up the ring are single bonded to other atoms. So in this, cycloalkanes are saturated as all the carbon atoms, they are making up a ring and they are forming a single bonded to the other atom. So these cycloalkanes are alkanes which are having the same carbon atom that are arranged in a ring. Means if it was a straight chain, then we have called it alkanes. And in the ring structure, we are calling it cyclo. Means it is in cyclic form. So that is, this is the difference between your alkane and the cyclo, that it is in the straight form, straight chain, and here it is in the cycloalkane is in the form of your ring form. So this is the definition of your cycloalkane. Next is your so because of the ring, a cycloalkane has two fewer hydrogens than an acycloalkane with the same number of carbons. So here that because of the presence of the ring, because of the ring, a cyclone has two hydrogen atoms that are less than a cyclic or a straight chain alkane with the same number of carbons. Because in a cyclic form, the two hydrogens are removed from there, and but in the chain, the two hydrogens are added in that. So, because of this ring form, because the cyclic ring is in the ring form, these are having the two fewer hydrogen. They are having the two less hydrogen than an non-cyclic alkane with the same number of carbon. But the number of carbon of this alkane and the cycloalkane are having the same number. But the hydrogens are, in case of your cycloalkane, it is less than your acyclic alkane. Next is your general molecular formula for cycloalkane is CnH2n. So in this case, the general molecular formula for your cycloalkane is your CnH2n. So here, if we are using one, we are taking n equals to one, then one, then CH2, CH2. But here it cannot be the structure. So here we are taking this two. So here, it will be our two C2H C2 H4. But this can also be not a structure. So here we are taking C3H6. So here C3H6 can be a structure, and that will be your cyclopropane. Means here C is your 3 and H is your 6. So here one carbon, 2 hydrogens are attached. So from the 3 carbon atom, 6 hydrogen atom will be connected, bonded. So the smallest or the beginning of this cycloalkane is your cyclopropane. So these most common cycloalkanes are represented as shown below. These cycloalkanes here we can also represent them like this also. Means the cyclopropane can be shown like a triangle structure, because triangle is having three sides. So the 3 sides are showing here the carbon. Then these are the carbon, these sides. Next, cyclobutane can be shown as a square structure. So this is your square, and square has 4 sides. So here it is having the 4 carbon atom bonded to each other. Next is your cyclopentane. So in case of cyclopentane, it's showing the pentane structure. So here this is your 5 carbons. 5 carbons are present here. That is why 1, 2, 3, 4, 5. This is your cyclopentane. Now hexane, in the hexane 6 carbon atoms are present, and the cyclohexane also, the 6 carbon atoms are bonded to each other, and with the 2 hydrogen atom each. So this cycloalkane, these cycloalkanes are alkanes. They are having the same carbon atom that are arranged in a ring, and the ring of different sizes beginning with 3 carbons are possible. Next, the cycloalkanes are saturated, since all the carbon atoms that are making up the ring are single bonded to other atoms. And because of the ring, a cycloalkane has 2 fewer hydrogen than an acyclic alkane with the same number of carbons. So here, because of the ring, a cycloalkane has 2 fewer hydrogen than a non-cyclic alkane with the same number of carbons. Next is your general molecular formula for cycloalkane is CnH2n. So the molecular formula for this cycloalkane is CnH2n, but in case of your alkane, it is CnH2n plus 2. So here, plus 2 means the removal, here minus 2 is having minus 2, 2 hydrogens are removed, or they are less in case of cycloalkane, and but both are having, means the cycloalkane as well as the acyclic alkane or a non-cyclic alkane, they are having the same number of carbon atoms. Next, the general molecular formula for cycloalkane is your CnH2n, and these most common cycloalkanes are represented as shown below. Your cyclopropane, cyclobutane, cyclopentane, and your cyclohexane. Sorry. Next is your isomerism. So the cycloalkanes have same molecular formula to that of corresponding alkenes. But the cycloalkanes are having the same molecular formula that of the corresponding alkenes. Means the molecular formula CnH2n is the formula for your alkene also. So they are having the same molecular formula that of the alkene. So they are the functional isomers with of same carbon number. They are functional isomers with the gene of same carbon number. That is why they are the functional isomers. Here example is given that it is your but2ene and but1ene and the cyclobutane. These are having the same molecular formula, but the structures are different. So all the above 3 structures have molecular formula that is a C4H8. But first 2 figures are functional isomers with the third figure. So here the third one is your cycloalkane, and the first 2 are your alkenes, and they are having the same, they are the functional isomers. These cycloalkanes are the functional isomers with this alkene, as they are having the same carbon number. So in case of butene, you can see here they are having the four carbon atoms are there in butene. In butane also there are four carbon atoms, and in cyclobutane also there are four carbon atoms are there. So here and the hydrogens that are present in this are the same. The hydrogen and the carbon quantities in this alkenes and the cycloalkanes are the same. That is why they are having the same molecular formula, but their structures are different because that is the alkenes and this is the cycloalkanes. That is the unsaturated hydrocarbon and this is the saturated. So that is why, but the first two figures, means butene and the butane, are the functional isomers with the third figure. Next is your now the nomenclature of cycloalkane. So how we will name the cycloalkane. So the rules for naming cycloalkanes are similar to that those used for straight chain alkanes. So first is your the parent ring is the largest ring in the molecule. Means you have to see the which is the parent ring, which is the largest ring in a molecule. Secondly, the parent name is generated by adding the prefix cyclo to the name of the alkane with the same number of carbons. So in this parent name, means that we have first we have to see that which is the largest chain. After that, we have to name that parent name, and we have to add the prefix that is the cyclo. And we have to also check that how many numbers of carbon atoms are there in the cyclane. So the cyclo is the name of alkene with the same number of carbon. Next, identify the substituent and their location by numbering the ring from the carbon containing substituent so as to give the substituents the lowest possible location number. So here we have to identify the substituent. What is the substituent that is attached to it? And after that we have to locate its location and locate its location by numbering the ring from the carbon and containing substituent so as to give the substituent the lowest possible location number. Then we have to alphabetize the substituent in the full name of the cycloalkane. First, the rule for naming cycloalkane is that in the first, what we have to do is we have to keep the largest ring. Which one is the largest ring or the parent ring? Next, we have to check that the parent ring. Sorry. So the parent ring is generated. The parent name. Now we have to name that parent ring. So that name we have to use the suffix or we have to add the prefix that is your cyclo in that name of the alkane. Next, we have to identify the substance. If any substance is attached to the ring, then we have to identify that substituent, and after that we have to locate the position of the locate the uh, position of that substituent on that ring by giving it a number, and after that so as to give the lowest, and we have to give the substituent the lowest number, and so as to give the substituent the lowest possible location number. Next, we have to alphabetize the substituent. If more than one or two, if more than one substance is attached, then we have to alphabetize the substituent in the full name. Means we have to if means if we are naming that full name, then we have to according to the alphabets, we have to name it. Next is your refer to the cycloalkane below to illustrate the nomenclature of cycloalkane. So here you will see that that this is the cycloalkane and this is the parent cycloalkane. Then the substituent, we have to see the substituent and we have to number it. So in this is the cycloalkane. Now what we have to see, first we have to see the parent ring. So here the parent cyclo ring is this. that is shown by the red color. This is the parent ring. Next, we have to see the substituent. These are the substituents that are attached to this cycloalkane. After that, we have to number this substituent. So here we have to see that which is the substituent that is having the that is having the long chain in it. So from there we have to start the numbering. So here we have started the numbering from this side: 1, 2, 3, 4, 5, 6. Now this chain, this parent name is your cyclohexane because it is having the 6 carbon atom. Next, next its parent name is your cyclohexane. It is cyclohexane. Next, the substituent. Now the substituent. What are the substituents that are attached or bonded to this ring? So here we will see that this is the first. This is your first number. So first number is 1, 2, 3. So this is your propyl. So here we are now going to number it 1 propyl. 1 propyl. On the second position, its name will be your 2-methyl. 2-methyl, because on the second position a methyl group is attached to it. So its name is 2-methyl. Next is your 4. 4 is your ethyl. 1, 2, 2 carbon atoms are attached to this fourth position. So this is its name is 4-ethyl. Now we have to alphabetize the substituent. Means alphabetically we have to write it. So first will E will come, then M will come, then P will come. So here the name will be 4-ethyl, 2-methyl, 1-propyl cyclohexane. So here the same 4-ethyl, 2-methyl, 1-propyl cyclohexane. So like this we have to nomenclate it, or we have to name this compound cyclohexane. Once again I am telling you that in this, while nomenclating this cyclohexane, firstly we have to choose the parent ring, which is the largest ring in the molecule. Next, what we have to do, we have to apply a prefix, that is your cyclo, to the alkane name. Next, we have, if any of the substituents are attached to the ring, then firstly we have to identify the substituent that which is the big substituent that is attached to it, or the large substituent that is attached to it. Then we have to locate its position by numbering the ring, and we have to give the larger substituent the lowest possible location number. Next, we have to alphabetize. Then we after and now we have to write the name. So before writing the name of the full name of this molecule, we have to alphabetize the substituents according to their alphabet. Okay, so here the example is given. So this is the molecule that we have to name it. This is the molecule. Firstly, we have to check which one is the longest, which one is the parent chain. So here the parent cycloalkane is shown by this red color. So this is your cycloalkane, parent cycloalkane. After that, we have to see the substituents that are attached or bonded to this cycloalkane, parent cycloalkane. So these are shown by this blue color. So red is the parent chain, parent alkane, cycloalkane, and blue are the substituents that are attached to this parent cycloalkane. Next is the numbering. Now we have to locate the numbers to this substituent. So here the first is given to this because it is having a large chain as compared to the other. Then this is the second because it is nearest to this. So here 1, 2, then 3, then 4. We can't number it like this: 1, 2, 3, 4, 5, 6. No, because this is methyl is nearest to this propyl. That is why we are giving it number 2. So this is your 1, 2, 3, 4, 5, 6. So this is your cyclo. This is the numbering of the substituent. Now we have to name it. So the parent cycloalkane is having the 6 carbon atom. 1, 2, 3, 4, 5, 6. So it is having the 6 carbon atom. That is why its name is your hex. So hex, it is having the single bond. That is why it is ane. hexane, and this is present in the ring. That is why its name is cyclohexane. So its name is cyclohexane. Next, now the substituent. The substituent on the first position is attached this chain. So in this is the carbon atom. One, two, three. So three carbon atoms are the propyl. The propyls are containing the three carbon atoms. So its name is propyl, because this is the alkyl group that is attached to this cyclohexane. So this is your propyl. So one propyl. Second, this is the methyl. One carbon atom is attached to this on the second position. So this is your methyl. So next is your fourth. On the fourth, this is the two carbon atom that are attached to this fourth position. That is your ethyl. So it's one propyl, two methyl, and four ethyl. So its name will be one propyl, two ethyl, four ethyl. Now what we have to do is we have to alphabetize the substituent. The alphabetize the substituents that are attached to this ring. So so first will come the ethyl, then methyl, then propyl. According to the alphabet, you can see E comes first, then M, then P. So its name will be 4 ethyl, 2 ethyl, 1 propyl, and the parent name is your cyclohexane. So here 4 ethyl, 2 methyl, 1 propyl, cyclohexane. So its complete name is 4 ethyl, 2 methyl, 1 propyl, cyclohexane. So this name is this molecule. Molecule name is this. Next example is that if larger rings take precedence over smaller rings. Now you can see here that the three rings are present in this molecule. So to whom we will give the preference first. So here the larger ring will get the preference first, and the smaller ring will act as a substituent to that larger ring. So here firstly we have to check which will be the parent cycloalkane. So this ring, the red color ring that is shown, is your parent cyclohexane. Cycloalkane. Okay, so this is your cycloalkane ring, parent cycloalkane ring. So here, this is a substituent. This is a substituent that is attached to this parent cycloalkane. This is the substituents. These are the that are shown with the blue color. These are the substituents that are attached. These are the attached to this parent cycloalkane. After that, we have to give the numbering. We have to number it. We have to give the numbering to this uh, parent cycloalkane. So here, from which ring is your bigger ring? Is that here? This is the bigger ring. After this ring, this is the bigger substituent that is attached to it. That is your cyclopentane. This is your propane, and cyclopropane. This is your cyclopentane. And on the first position, it is having the 1, 2, 3, 4 carbon atom. And on the second position also, there is a substituent that is attached to here. So here we are going to number. Firstly, we will choose the parent name, that is your cyclohexane. Then on the one position, that is your cyclopentyl. Here we are using the cyclopentyl, cycloalkyl. So its name is cyclopentyl. So on the first position, cyclopentyl is there. On the second position, cyclopropyl is there. And on the fourth position, this cyclobutyl. But on the second position, there is bonded a methyl group. So this we have shown with this dash. First dash, 2 dash, 3 dash, 4 dash. So on the second, there is a 2-methyl, 2-methyl, 2 dash methyl. Then this is your butyl. So its name will be 1 cyclopentyl, 2 cyclopropyl, then 4 2 dash methyl butyl. Fourth 2 dash, fourth 2 dash methyl and the butyl. On the second methyl, and it is your butyl. to alphabetize the substituent. Now we have to alphabetize this substituent, and after alphabetizing, we are naming it. The complete name will be 1-cyclopentyne, because after the P, this whole is same up to this P. After the P, E will come first. Now after that R comes. So its name is 1-cyclopentyne, 2-cyclopropyl, 4 to within bracket 2-methyl butyl, and cyclohexane. So this is the name of this molecule, and sorry. So how again I'm telling you that if the more rings are attached, if the more rings are present in a molecule, then what we have, how we will going to name it. So here, firstly, we have to choose the bigger ring, and which one will be the bigger ring. So in this, the parent cycloalkane, you can see the red color ring, that is the bigger ring as compared to these two rings that are bonded to this bigger ring. So next we have to choose the substituent. That what will be the substituent in this case. So here the substituent will be your this shown shown with the blue color. So this blue color is your substituents that are attached to this bigger ring. Then we have to give the number to the ring where the substituents are attached to it. We have to identify the substituent. After that, we have to locate the number of that substituent. So we have identified in the second step. Now we are giving it the numbering, and next is your 1. On the 1 position, there is your on the 1 position, a cyclopentyl group is attached. On the second position, a cyclopropenyl group is attached, and on the 4th position, there is this chain is attached to it. So the parent name will be your cyclohexane, and the substituent that are attached to it, they are the 1 cyclopentyl, second cyclopropyl, and on the 4th position there is a second 2-methyl butyl, because in that chain there is a one more substituent is attached. That is why we are numbering it 1-, 2-, 3-, 4-. So its name is 2-methyl butyl, and after alphabetizing its name, the name will be your 1 cyclopentyl, 2 cyclopropyl, and on the 4th 2-methyl butyl cyclohexane. So its name will be complete name will be 1 cyclopentyl, 2 cyclopropyl, 4 2-methyl butyl, and cyclohexane. So this is the name of this molecule. Next is if the alkyl group has a larger if the alkyl group has a longer carbon chain than any of the ring, the straight chain system will be the parent chain. If the alkyl group is having it is having the straight chain system will be the parent chain. If there is alkyl group having a longer carbon chain, if there is a longer chain that is present in a molecule, and it is also having a ring, then if the chain is a longer, then we have to make that ring. Sorry, we have to make that chain parent alkane, and the rings to be the substituent. So here, if this is the molecule, in this molecule, we can see that this is the parent alkane. 1, 2, 3, 4, 5, 6, 7. So 7. This is the parent alkane that is shown with the red color, and after that the substituent, and the substituent is shown with the your blue color, and after that we are naming it. So the parent longer chain So the carbon chain that is the longer carbon chain that is having the carbon chain, seven carbon chain, and on the first position there is a this cyclo ring is attached to it, and on the third dash position there is a cyclopentyl. The cyclopentyl on the fourth position is attached. That is why we have the numbered it like this: the one dash, two dash, three dash, because on this ring, two more rings are attached or bonded to this main ring. So that is also here. The substituent will be your three dash or three dash cyclopentyl 4 dash. Okay, first the pentyl will come. So on the first position, you can see one on the one carbon atom, there is this full cyclohexyl is present, and in the fourth position, this cyclopentyl is present, and in the third position, this cyclopropyl is present. Its name is 1 4 dash cyclopentyl, 3 dash cyclopropyl, cyclohexyl, then 6 methyl, and the substituent, after alphabetizing the substituent, here the complete name will be 1 4 dash 1, this 4 dash cyclopentyl, cyclopropyl, and this is whole is your cyclohexyl, and on the sixth position a methyl group is attached. Its name is 6-methyl, then heptane. So this chain is having a 7 carbon atom, so its name is heptane. So again, if a alkyl group has a longer chain, has a longer carbon chain, then any of the ring, then the straight chain system will be your parent chain. Then the straight chain system will be your parent chain. So here the parent chain is your this that is shown with the red color, and next is your this substituent are attached, that is your blue color, and after that here numbering. So numbering is given 1 2 3 4 5 6 7, and here you can see here 1 dash 2 dash, the substituents are numbered at 1 dash 2 dash 3 dash 4 dash 5 dash 6 dash, because it is a 6 cyclohexane in this, and on the third position 3 dash position a cyclopropane is attached. On the 4 dash position its cyclopentyl is attached here. So here it's a substituent that is your on the first one, and within bracket we will write here 4 dash cyclopentyl, then 3 dash cyclopropyl, and cyclohexyl, and after that 6-methyl, and after that we are alphabetizing this. First this cyclo C will come, and after that M will come. So here its name is 1 dash 4 dash 1 hyphen 4 dash cyclopentyl, 3 cyclopropyl, cyclohexyl, then 6-methyl heptane. So the complete name is cyclo. This is the complete name of this molecule. Next is your. It can be read in three section also. Naming of simple cycloalkane. It is done by attaching the prefix cyclo to the name of the corresponding normal alkane having the same number of carbon atoms as in the ring. For example, this cyclopentane, cyclobutane, cyclopentane, and cyclohexane. Next, name of the substituent cycloalkanes. That naming of substituent in cycloalkane as shown in first figure below are similar to that of the straight chain compound. But in the second compound, which is a fused cyclo chain, is typical. This is your fused cyclo chain. So this naming it is a typical. So let's break the name bicyclo 2,2-1. So bicyclo, this is the bicyclo molecule, and bicyclo molecule, and it is 2.2.1 heptane. It is having the 7 sided. So bicyclo implies the compound that is having the two ring. It is having the two ring. If we break two carbon bonds, the compound will be alkane of seven carbon and can be heptane. It means if I'm breaking this two carbon atoms bond, then it will be a seven carbon atoms, seven carbon, and it can be your heptane molecule. So now the most important part naming of 2.2.1 is that it is so named because the number of carbon except bridgeheads and shared carbon is 2, that is your C2 and C3, and 2 C5 and C6, and the bridgehead made of one carbon, and one carbon is your C7, and it is your so here how we can name is bicycloheptane, that if we break the two carbon atom from here, then it will become a alkane, that is your heptane. Okay, now the most is that it is so named because the number of carbon atom except this bridgehead share the C2, C3, and C5, C6, and the bridgehead is having C7, one carbon atom. So here that is why it is named 221. Means two carbon, and the one carbon. This is your this is your bicyclo 2.2.1 heptane. Next typical example of typical cycloalkane. So these are the typical cycloalkanes that are given below. These are the typical fused cycloalkanes, and in cubane each carbon attached to three other carbon, and in diamond each carbon attached to four carbon atoms. For ring with more than one substituent, begin numbering at one substituent and proceed around the ring clockwise or counterclockwise to give the second substituent the lowest number. So here you can see this is the numbering, how to give its numbering, that 1, 2, 3, 4, this is the correct numbering. And this, if we are counterclockwise, we are doing the numbering from this side, then it will be a wrong number. Next is your with two different substituents, number the ring to assign the lower number to the substituent alphabetically. Here we have to number it the lowest number to the substituent which is having the large number of carbon atoms. So here the here you can see that here from here this is the incorrect system, and we are numbering this methyl first, and then the third we have given this number. But here we are numbering the ethyl group first and then the methyl group. So this is the correct numbering. So first we have to give the ethyl, then we have to give the numbering to the methyl. When three or more substituents are present, begin at the substituent that leads to the lowest set of location. Means here if the three substituents are attached, then we have to name it to the this 1, 1, 2, 3, 4. So here we are going to number it like this. 1, 2, 3, 4. 1, 2, 3, 4. So its name will be 4-fluoro, 2-methyl, 1-methyl cyclohexane. Next, when an alkane is composed of both a ring and a long chain, then the ring is the parent hydrocarbon unless the substance has more carbon than a ring, which I have already told you in the last slide. So here that it is having the 6 carbon in the ring, that is why it is chosen as a main parent ring, and this butyl is having the less carbon atom. So here if this is having, this chain is having the large number of carbon atom, then this will act as the parent chain and this will act as the substituent. Next is your alkyl chain has lesser number of carbon and is written as a prefix. Next is your alkyl chain. In this you can see butyl cyclopentane. So it is your pentane and it is having, this chain is having 4 carbon atoms. So it is used as a prefix. So in this is your pentyl and this is your 1, 2, 3, 4, 5. So both are having the same. So pentyl cyclopentane. In this case, you can see this chain is having the more carbon atom, and this is having the less. This ring is having the less number of carbon atom that are bonded. So this will act as a substituent, and this chain will act as a main ring. So its name will be the ring containing lesser number of carbon, and is written as cyclopentyl. So its name is 1-cyclopentyl hydride. Next are the physical properties of the alkane and cycloalkane. A series of compounds where each members differ from the next member by a constant unit is called as homologous series. So members of a homologous series are called homologs. So at room temperature, that is room temperature is 25 degrees centigrade and 1 atmospheric pressure, and the C1 to C4 unbranched alkanes are gases, and from C5 to C17 unbranched alkanes are your liquid, and above the C18, above the unbranched alkane with C18 or more carbon atom, they are all solids. So at room temperature, the C1 to C4 carbons are gaseous, and C5 to C17 are liquids, and above C17 or you can say above C18, these are all solids. Next is the boiling point. The boiling point of the alkane increases with the increase in the molecular mass. That is, the higher number of carbon in the alkane, higher is its boiling point. So as the molecular weight of unbranched alkane increases, so too does the molecular size. If the molecular weight of the unbranched alkane increases, then the molecular size will also increase, and this molecular surface area will also increase, and this will increase the van der Waals forces between the molecules, and there will be high energy required so to separate it from one atom to the another. That is why they have the high boiling point. For isomeric alkanes, where the molecular mass is same, the boiling point decreases with increase in branching. As a result, an increase in branching causes a decrease in surface area, and as a result, the intermolecular forces of attraction decreases, and therefore there decreases in the boiling point. The density. So the density, the alkene and cycloalkane are the least dense of all group of organic compounds. Next is the solubility. The alkane and cycloalkanes are almost totally insoluble in water because of their very low polarity, and they are unable to form hydrogen atoms. And these alkanes are soluble in organic solvents, and liquid alkenes and cycloalkanes are soluble in one another, and they are dissolved in solvent of low polarity. Next, the question. Cycloalkanes are associated with the general formula, that is your D. Cycloalkanes have the same melting and boiling point as their corresponding alkene, that is false. Identify the incorrect statement regarding cycloalkane. These are sp3 hybridized. They have tetrahedral bonding. The stability of the cycloalkanes derives directly with their respective size. These undergo nucleophilic substitution reaction. So the option B is correct. Next, identify the compound with the highest ring strain, that is your cyclomethane. Which among the following compound explode on contact with oxygen, that is cyclobutane. Identify the smallest alkane which can form a ring structure, that is the cyclopropane. These are the references from where you can study this topic, the cycloalkane. And thank you so much for today's lecture.